and we are involved in many national and European research projects, also worldwide research projects that are focused on cloud computing in particular and related services, exascale distributed storage, and in general cloud system and edge-enabled intelligence system, which will apply machine learning and deep learning techniques in order to, let's say, fill the gap between the academia and the industry. The focus of this workshop is aimed at bringing together people coming from academia and industry that work in the area that I mentioned, that are basically machine learning, data analytics, and deep learning, in order to have a technical presentation and share their, let's say, knowledge in order to, let's say, instaurate in some way a good relationship and exchange idea in order to have active collaboration. This is a brief presentation of the institution that I'm representing and also the focus and the topic of the AMDA workshop that is going to start right now, with the first presentation from Elisabetta Ronchieri, which paper ID is 398. And Elisabetta, you can share the screen as you like. And she is as well from INFN, and she will present us today the activity and the work for software defect prediction on unlabeled dataset, a comparative study. Please, Elisabetta, the floor is yours, and you can start the presentation.
Okay, good morning. During this presentation, I will show you some results and considerations about the comparison of various approaches in prior unlabeled dataset to predict the defective modules. Software defect prediction is used to determine software modules that are likely critical. This means that these modules may require particular attention during the development and maintenance phases. Not necessarily they will include bugs or defects. This software engineering problem can be addressed by using machine learning techniques as documented in literature. Most of the existing studies have applied supervised learning techniques to label datasets. However, software projects, especially the new ones, usually lack classification labels, and therefore, in this case, unsupervised learning techniques can be used. Unsupervised software defect prediction exploits clustering and non-clustering approaches that are applied to software datasets. These datasets include software metrics and not contain any classification or labeling information. The labeled datasets employed in the existing studies, like NASA and PROMISE datasets, derive, for example, from experts' opinion or threshold cutoff values and are not well documented. Furthermore, they also include different software metrics, and it's not easy to compare the results. So in this study, we use a new unlabeled dataset extracted and preprocessed from C++ code related to Jam4, that is a high-energy physics software project. This new unlabeled dataset is a multi-release dataset characterized by 34 releases delivered over 20 years of development of Jam4. This dataset does not include all the releases, especially the last one. It stopped at the 10.4.0 release. The dataset includes different software matrix categories such as size, complexity, and object orientation, and these have been measured by using an Imagix 4D tool, and the dataset cover class and file level information. To label this dataset, CLAMI, CLAMI Plus, and K-means approaches have been used. CLAMI stands for clustering, labeling, matrix selection, and instance selection, whose key idea is to label unlabeled dataset by exploiting matrix magnitude or mean, such as mean or other quantiles that are used as matrix cutoff threshold. CLAMI Plus is a CLAMI improvement, and K-means is an alternative, is a complementary approach to CLAMI and CLAMI Plus for the clustering phase. Then the prediction phase has been carried out by using various supervised classifiers belonging to six categories, such as decision tree, ensemble, near neighbor, and so on. And each classifier has been evaluated by using different performance metrics. The figure shows the general workflow of software defect prediction on a labeled dataset. It is based on CLAMI that is characterized by 4 phases. Clustering, where modules are grouped, labeling, where violations of a module are counted, matrix selection, and instance selection, where informative features are selected. CLAMI Plus is an improvement of CLAMI in the clustering phase, where the difference between the matching value and the threshold are transformed into probabilistic value. The unlabeled dataset is split in training and test datasets. The first for the train phase and the second for the prediction of the defects. The training dataset starts unlabeled and ends labeled after operations derived from CLAMI and number from 2 to 3 in the figure. Concerning the results, they are based on a subset of the whole dataset. To conduct a reasonable comparison among the various releases, we have considered the modules that were present in all the releases. This means 482 modules per release. And in the labeling phase, we have determined modules that may contain defectiveness and introduce either buggy or clean labels for each module. The selecting matrix change according to the approaches used, and they go from a minimum value of 18 to a maximum value of 52 in the various quantiles. We have determined the percentage of defective buggy modules and the total modules of the releases for each quantile. The percentage has been calculated for the CLAMI and CLAMI Plus approaches, and we observed a deviation of plus minus 10% in the results. The plot here shows this percentage, the difference of this percentage between CLAMI and CLAMI Plus for the various releases and the various quantile adapted as a threshold. Furthermore, during our manual check on the existing documentation, we have covered 380 defective models in all the releases, and the plot here shows the correspondence found in the CLAMI and CLAMI Plus approaches. Concerning the K-means algorithm, we applied this technique to the whole data set composed of 482 modules repeated for 34 releases. It has provided two clusters characterized by different modules. The plot on the left shows the relation between the modules in the two clusters and existing documentation of the effectiveness. The plot on the right shows the relation between the modules in the two clusters and the labeling results obtained by CLAMI and CLAMI Plus. Concerning the machine learning techniques, we have applied these techniques with the cross-validation in order to avoid overfitting. We have excluded all the machine learning techniques whose kappa statistics scored a value less than 0.80 in order to omit a low agreement between actual and predictive values. For the comparative analysis, we just consider J48, LMT, AdaBoost, and bugging machine learning, for which we have measured the average rank calculated on the various performance metrics. Then we use statistical tests to determine deep comparative analysis between among the various the remaining techniques. CLAMI obtain a good results for according to the AUC performance metric, while CLAMI Plus for all the other performance metrics. We have not observed significant difference between methods. And according to the squad knot AST test, EUC shows that bugging is the most influential technique for both CLAMI and CLAMI Plus approaches. With this study, we are able to answer 3 research questions. The first one asks which unsupervised approach performs best in terms of performance metrics. CLAMI Plus obtained a best accuracy compared to CLAMI, almost 96%, while CLAMI obtained better results for the other performance metrics. Concerning the second research question, we can say that AdaBoost achieved the best score in accuracy recall and AUC, while J48 and bugging obtain best results for CLAMI Plus in relation to accuracy, precision, recall, and F measure. The last question is related to the cutoff thresholds used in the comparison results. We decide to use different values because the current data set does not show a Gaussian distribution. For this reason, it's not enough to consider just the median or the mean values of the thresholds. In the future work, we are going to repeat to extend the study by considering the whole data set Gen4. This means use the all modules information, not just the 482 modules for release. And the idea is to extend the approaches, the unsupervised techniques approaches, comparing the new ones with the traditional one that we used in this study. Okay, thanks for your attention. There are any questions?
Thank you, Elisabetta, for this nice presentation. And yes, there is any question from the platea to Elisabetta? I have one, if no other is raising the hand. So basically, just one quick question. Okay, the question is quick, but I don't know the answer. Or of course, have you in mind? Have you scheduled to use this, say, technique, this software prediction technique, to also other software different from the one that you mentioned? No, I don't know. In particular for this for other software, maybe not related to physics.
Well, we're just starting considering other software related to high energy physics like Root. We already collected the matrix for this software. We are intending to apply the same methodology to software that are used for data libraries, but they are still related to physics environment. At the moment, yes, the software considered are related to physics background.
Thank you, Elisabetta, for your nice presentation and for answer to this question.
Thank you.
So, as from the schedule, I passing the floor to Roberta Damasevicius from from Kaunas University of Technology in Lithuania, Robertas, and you will present us the body lock human identity recognizer app from working activity data. Robertas, the floor is yours for this session.
Thank you. So first, I would like to introduce some context and motivation of our research. We all use smartphones primarily for communication, also for entertainment, and the security of our personal data is very important because nobody wants to use your personal emails, your personal photos. Also, with a trend to bring your smartphone to your work and also use it for checking official emails, also to do some small works. So this trend is called bring your own device, and that's why the security of the personal smartphone and ensuring the security of identity against loss or theft of a phone becomes very important because not only the loss of a personal data is threatened, but also the loss of very important business data can be lost. Of course, there are traditional methods to ensure the security of a device, such as password-based, but passwords also have their own limitations, such as they can be cracked, they can be forgotten, or they can be lost. Biometrics methods have started to be used to increase the security of a device, but they have their own limitations, such as, for example, they require some additional equipment or higher quality equipment, such as, for example, a high resolution sensor to recognize iris, or they require some special environmental conditions, such as a noise-free environment to have a good quality voice recognition. And also biometrics have their own disadvantages, such as non-repeatability, because they are not constant, they change from time to time, and also non-revocability, so that you cannot revoke your own biometrics, like you cannot change the shape of your face, for example. So in this research, we analyze the recognition of identity and adding additional security by using the walking behavior characteristics of the human, so-called gait, and such biometrics is very convenient because it does not require additional sensors when those sensors which are already included in the most modern smartphone models or smartwatches. To discuss the main characteristics of gait, you have to consider that gait changes from time to time, and there are slow changes like introduced due to aging, which can take a long time, but there are also short time changes which may be caused, for example, by the change in the emotional state of a subject, well-being, also fatigue, some injuries or illnesses, or even surface conditions and type of shoes, which may greatly affect the gait characteristics of a person. They also depend on the input signal quality, because if the quality of the sensor is low, so of course the signal will be contaminated with noise, and it will be more difficult to recognize the gait characteristics and to identify the subject. So the main challenge is to overcome these difficult conditions and to extract reliable features from the signals, such as accelerator signal or gyroscope sensor signals, to make personal identity recognition possible. Also, the developed system must continuously trace the characteristic of the human walking every day, so that every change, such as change of the well-being or emotional characteristic, should be used to retrain the model so that the recognition still stays reliable. So the aim of this research is to analyze human gait characteristics for monitoring the state and identity of a smartphone user, to discover features which can distinguish the changes in the state or condition of a smartphone user reliably according to his or her gait parameters, and also to develop an additional active layer of protection of smartphone device, which could be used in case of any change discovered, to invoke an additional stronger authentication measure, such as, for example, mandatory locking of a device until the user will use some additional method to authenticate his identity. And the aim is to create and validate a passive user authentication system that can be operating on a portable mobile device and will allow the device owner to be distinguished from any other subject based on the tracked parameters of his gait. So for this, we use a standard machine learning methodology, which is based on acquiring the data from the sensors, performing preprocessing of this data by removing outliers and filtering and normalizing data, then extracting features, reducing the feature space, detecting the specific activity that the user is engaged, such as going forward or going up the stairs, and then creating the gait model of a specific user, which is continuously updated to sense any changes in his state. So the developed app on the Android operating system has a fairly standard architecture. It has glasses to capture the signals, to calculate features, to send the calculated features to the server. Server then performs classification and returns the state of the device owner. For data acquisition, we use the data which comes from the acceleration server sensor, from the gravity sensor, and from gyroscope sensor. So each sensor returns data in 3 axes. So in total, 9 raw data features are used, and we perform the normalization of this data, smoothing, and outlier removal, so that any external disturbances may be caused by some, for example, electrical devices may not influence decisively the classification result. And we calculate features over sliding windows over sensor data. We use 100 data points returned by standard resolution of the sensors with overlap of 50%. And for this task, we explored a very large number of various gate features. The total number was 102 features explored. You can find the more detailed description of these features in our other papers published. Here on screen, you can see only example of some of the features, and you can see that mostly these features are some mathematical calculations performed over signal values, such as calculating the intensity of the signal, the difference of the signal, also some statistical data, statistical features. And for collection of data, we used our research building, which has office type premises, and mostly you can see that the data collection environment consists of some very long straight corridors up to 50 meters long, as well as stairs going up and going down. So we took 13 subjects which performed data collection while having the smartphone with installed developed application put in the trouser pocket and walking around this office building. And we performed data collection in the first part of the day in the morning, so that to avoid any fatigue effect which may influence the collected data. And here are some of the results. First of all, we recognized the type of activity, so walking forward or walking upstairs or downstairs. And once the type of activity was recognized, then we performed the identity recognition. And for identity recognition, we used binary classification, so it was recognition one versus all other subjects, because for this type of task, it is important to distinguish between the host or owner of the phone and all other subjects which may try to steal this identity. And on average, we achieved 97% of accuracy of correct identification. And if we consider the features which were most discriminated or recognition, it was the statistical features, mainly 95 and 99th percentile of acceleration, which means that the more extreme events in walking, such as sudden movements, had a distinguishing role in recognizing the identity of the subjects. So to discuss some challenges and limitations of this research. First of all, the contamination of data with noise was a problem, because in some cases we have encountered some spikes of values in the raw data, which may have been caused by some electrical or some other research equipment which was located in this building. So we used the outlier removal procedure to remove all values which were different by more than 4 standard deviations from the mean value. We also observed the high interclass variability within the same subject, because for gait, the particular type of shoes or even clothes or flooring conditions may have a great impact. And also we noted that although interclass similarities were large, the limitation of the study was a small number of subjects, and if we collect data from a larger number of subjects, this feature space will become more densely packed with data, and it may be more difficult to recognize the identity of the correct user. So we can conclude that we confirmed that using human walking as a biometric characteristic, we can improve user authentication on the go. So by continuously observing the walking parameters of the smartphone owner, we achieved the 97% accuracy of identity recognition with features generated from data acquired from the acceleration and gravity and gyroscope sensors, and we used a simple linear support vector machine classifier to perform binary classification 1 versus all other subjects. And the developed app allowed to deploy an extra security level on portable mobile devices, which continuously observes the identity of the user, and in case it decides that the owner of the phone has become a different person, so someone captured the phone, it locks the phone and sends an email to the predefined account asking for the user to confirm his identity using other means of security. So thank you. Any questions?
Thank you, Robertas, for this presentation. Question?
Any questions?
Actually, I have one for you. If no other, raise the hand. So, the data that you are collecting become to start are actually can be considered also personal data or private data, because
Yes.
they can be used also for authenticate a guy, a people, a person. So what about security in this sense? Security in terms of preservation of the data, security in terms of let's say protection of the data, etc.
Yeah, the collected raw data stays on the phone, so the owner doesn't share it. The app only sends the data of some calculated features from the signals. So just from these features alone, the original gate parameters cannot be restored. So we think that by only sharing with the features, calculated features on the signal data, the user actually does not share any private data, because from features, the original data, private data, cannot be restored. It's statistical features, not any kind of features. Is it clear?
Okay, thank you. Other question, Roberta?
I have a question.
Please.
Concerning the preprocessing part, did you already tested if the user change a phone and so the model could also change because the hardware is different and the preprocessing is useful for this part, or doesn't do a lot of stuff to normalize to have the same data from the same user, because you pair the user to a smartphone in this process, no?
Yeah, because we collected data both for positives and also for negative class. So during collection, the subjects first used their own phone and then they exchanged their phone so that we can collect data for the negative class. And for preprocessing, we used some smoothing methods mainly aimed at reducing the noisiness of the signal.
Oh, okay, understood.
Okay, many thanks to both
Thank
of
you.
you. I then switch to the next presenter. Many thanks, Roberta, for this kind presentation. So the next presenter is Mirko Tracolli. Please, Mirko, starting to share your screen. The paper ID is 275, and Mirko is from University of Perugia in Italy, and he is going to present today the work with the titled on Intelligent Cache Management for Data Analysis at CMS. Mirko,
Yes,
the floor is yours, please.
Can you see my slides? Yes?
Yes, I can.
Okay. I'm Mirko Tracolli. I'm presenting you a smart caching content management study on smart caching content management, and speaking on behalf of several people. I want to thank them all for their contribution too. So in this presentation, we see some information about the context, what we measure in our test, and the approach we used to enhance the cache content. And I will show you some test results, and of course the future steps of this work. Starting from the context, we focus on the high requirement computational storage power of the next upgrade of LSC. In the next year, the hardware will be a critical point, and also the cost due to the data storage is quite a nice problem. So the current storage system is centrally managed and has hierarchical structures and that are moved manually. One of the proposed solution to deal with this upgrade and the new amount of data that will come from the next year analysis is a data lake, and this infrastructure, this model will reduce the number of the endpoint where the client has to request the data, and it has the infrastructure that can autonomously manage the data flow and inside the network. These autonomous data are moved on using a cache system inside internal nodes. This distributed cache is transparent to the end user that doesn't know about it, and has the target to optimize the traffic to the real custodial center.
Sorry to interrupt you.
Yes.
Oh, okay. I couldn't see the slide, but now yes.
Oh, sorry. Maybe this is the connection. Okay.
Okay, go on. Sorry to be interrupted.
No, don't worry. So this This distributed cache, as I said, have to optimize the data traffic through the custodial center that are the main storage of the data. And to do so, we analyze the scenario that you can see in this schema. For example, this is the base environment. We have a cache that deals with the client request and the central data storage. We want to measure the bandwidth that the cache used to retrieve all the data and the flow of the read data to the client. So basically, these are the main value that we want to monitor. To do so, we create some measure that can show us how our behavior, how the cache behavior affected in base of different algorithms, and you can see here how we use that value from the schema. And to do so, because it's related to the distributed cache with the CMS workflow, we integrated a plugin to the Xcache object. This Xcache is the basic object that a user can use to retrieve data, and we can write a plugin to filter the request from the user and choose what to write or not inside the cache memory. So we are making a plugin that do this suggestion for us. The target of this approach is to maximize the throughput, so we want to write less inside the memory, and we want to maximize, of course, the read from the cache, the read output from the cache. The approach is using a file weight, so we want to measure how a file is weighted, and the target is that we want to store in memory just the file that weight less. And to do so, we experimented three different equations that take into account the features directly from the file F at the time t. For example, here you can see that we take the number of requests, the size, and the delta time from the last request with a certain parameter alpha, beta, and gamma. We will test this equation during the simulation to have a better cache content. So these tests are made using a real historical data request from the year 2018, the year request of the user data analysis taken from CRAB, and there are a lot of requests from any region, so we filter the region Italian to do this test, and there are at least 10,000 requests per day, and the file size is from 1 gigabyte to 16, but there are also some files that are bigger. Using this data, we create a test bank to evaluate the different equations, the different algorithm impacts on the cache content management, and we choose to as a cache size 100 terabytes with the bandwidth of 10 gigabytes with the central custodial storage. The parameter of the configuration that we saw in the equation are are described in the slides, and we tested each value for the parameters. As you can see here, we report just the more relevant results. The LRU is the standard policy adopted by Xcache, so this is the main comparison that we have. And here you can see the best results for each equation. And as we saw from the results, the throughput and the costs are have a very great improvement respect to the LRU policy, but I didn't show here with the measure. We have to improve the bandwidth and the CPU efficiency that we already monitored, but for time relevant, and I don't put in this table. So starting from here, we want to improve the hit and miss ratio of the cache system. We want to optimize also the network, because it's very important to maintain the cost of the infrastructure. And we want also to study the relationship with the client request and CPU efficiency through the cache system. And as a summary, we can say that the cache content management is crucial because of the requirements are growing so high. And with the better content management, we can have a more efficient flow of data analysis and a better user experience. Of course, we use just the file features, so we can also add some domain-specific information for a better cache content. And also the measurement are not trivial, because we are several aspect to control, starting from the user experience to the infrastructural cost. So we have to take into account for the future step also this different type of fields. Thank you so much for your attention, and if there are some questions.
Thank you, Mirko, for this say short but dense presentation that you showed to us. Are there any questions to Mirko? Actually, I have one, but maybe two. And you said in your slide that you have to take care, Mirko, of some aspect of this activity. And for example, CPU efficiency, network utilization, disk, and so on. The first question starting from this is how you are thinking to, let's say, improve this aspect. And then the question, at least from my side, is how this solution can scale.
So for the first question is just how to measure the impact of the bandwidth and, for example, also the CPU efficiency on the file weight. For the bandwidth, we can also have a precise information during the request, because we know already how much we spend to retrieve a file. But for example, the CPU efficiency is a delayed information. So to update for example, to update the weight of the file, we have to wait for an amount of jobs or amount of tasks that ended, and then we can say that we use an amount of CPU with that file. We just started to test this stuff because we use historical data, so we already have this information, but it's not in real time. To respond to the other question, to scale up is simple. Use more is implicit to the Xcache management, because this algorithm, this plugin is for cache. So you can put more cache that collecting data from the user request, and they collaborate together to that stuff. So it's not the problem of the evaluation function. It's just on the mechanism that the cache share the information of the files. So you can have also a decentralized database for the file features, and that's not a problem. The function is punctual, so it does not require a lot of compute time. I don't know if I respond all the question well.
Yes, thank you, Mirko. Thank you, you did. Other question from for Mirko? If not, Mirko, thank you for this nice presentation.
Thank you.
And I invite the next speaker, which is Fabrizio Alfonsi, to be prepared and share the screen. Fabrizio, are you here?
Yes, can you hear me?
Yes.
Yeah, I'm waiting that the last presenter remove the sharing because I can continue.
You can share. The presenter should be. So basically, Fabrizio is from.
Can you?
Yes, Fabrizio.
Can you see?
I put your screen. Just a moment because I'm just presenting you. Fabrizio is from University of Bologna. The paper ID is 399, and he is presenting today the work with the neural net on FPGA, a machine vision algorithm applied to means dataset using HLS for machine learning library. Fabrizio, the floor is yours, please.
Okay, thank you. Can you hear me well?
Yes.
Okay, thank you. First of all, good morning, everyone. I am a PhD student from the Bologna University, and today, as the presenter already told, I will present you an application of neural network on FPGA, in particular a machine vision algorithm applied to the MNIST dataset, using a particular and free available library on internet, which is called High-Level Synthesis for Machine Learning. I hope that you can see my slides change. So in the next slides I will introduce you why the reason of this test implementation, and I will introduce you very briefly to the high-level synthesis for machine learning library. Then I will describe you the editing and compression on the dataset and on the model that has been chosen to do the...
Sorry, Fabrizio. Sorry for interrupt you, but you are stopped in the first slide.
Okay. Can you see now my slides change?
No.
Okay.
Now yes.
Okay. Now can you see the slides change?
Yes.
Okay, so probably I can't share a full screen. Okay, fine, thank you. So, as I was saying, after the editing and compression of the model, there will be the implementation of the FPGA, the laboratory test, the results of this test, and then the conclusion. So, in the last years and in the next one, the increase of requests for the implementation of what we could call hardware algorithm, which we could describe them as complex computational algorithm, as for example tracking algorithm for high energy physics, increased. This algorithm further than complex computational feature, they must have an important characteristics, which is the complete control of the latency, to be able to have a computational time with a precision at nanosecond. To be able to to develop this kind of implementation, the two devices required are the field programmable gate array, FPGA, and the application-specific integrated circuit, or the SAIC. Now, to demonstrate the capability of FPGA for this type of task, I will show you today the library HLS4ML, High-Level Synthesis for Machine Learning, which is an available library on internet that, starting from Python's tool like Keras, TensorFlow, PyTorch, is able to build neural network or machine learning model, training it and working on it, and after editing and compression operation, this library is able to build a real firmware, a custom firmware designed to be implemented on FPGA. So the chosen dataset is the MNIST1, which is a set of 70,000 images and written image that represent a number from 0 to 9 in pixel images with a resolution of 28 by 28 pixel and 8 bits of gray. The idea for this neural network that is shown in the figure below of the slides is of course recognize the number written on the image. The resulting neural network is a 4 layers one that taking input the image and put in output 10 nodes that where each one represent the number from 0 to 9. To be able to implement this on FPGA, a set of operation that respect the library constraint and the resource reduction of the FPGA have to be done. First of all, an editing of the dataset that consisted of a cropping and a downsampling of the images. This was a constraint required by the library HLS4ML to be able to process these images, and these two operations transformed the images from an 8 by 8 pixel and 5 bit gray. After editing the dataset, the training of the model has been done, which after 15 epochs led to an accuracy of 94%, as the image on the right part of the slide show. After that, another operation of, in this case, compression has been done. A compression that explore a feature of the library HLS4ML, which is remove unnecessary operation, for example, multiplication by 0. In particular, in this case, was the multiplication operation of the weights of the neural network, and to gain from this feature, it has been done a pruning operation, which is a substitution of the value of the weights below a certain value with the value 0. This allowed to reduce of almost 50% the number of parameters required by the neural network. After that, the last fine-tuning is the choice of the data type that the FPGA has to deal with, because of course FPGA are a binary system, so the number of integers and floats with which the variables have to be described is an important task to choice. The features to take into account are, of course, the sign of the number, the minimum number of integers and floats required to describe the number, and of course the correct description of the parameter space. These 3 points, together with another one that I will show you in the next slides, led the 3 important variables, which are the weights, the last layer probabilities, and the input data, to have the configuration of numbers of integers and floats shown in the below part of the slides. So, as I said, there is a four other feature to calculate correctly the number of, in this case, integers, and which is the correct calculation of the maximum number which every node will have to deal with. And to do this, a new parameter has been added, which is the one showed from the green rectangle, and which is the maximum number of nodes in input received by the receiving node. This the adding of this parameter led to calculate correctly the maximum number received by the nodes A, the value, the number A, which is calculated by multiplying the maximum weight received by the node by the value of the previous node, and again by the maximum number of nodes in input. This operation was required to prevent the overflow, and the formula shown in the below part of these slides represent the formula used to calculate the number of integers of the variables. So, after completing all the fine tuning and built the final firmware, the test on the laboratory has been done. Test shown in the below part of the slide by the photo that shows two FPGA-based cards. The bigger one, which is the computer, the brain that processes the algorithm, and the smaller one, the smaller cards that has been used as service one to display on screen the images in that moment processed by the neural network. To be able to communicate with the algorithm inside the FPGA, the switches and the LEDs of the bigger cards have been used. The switches to move from an image to another, and the LEDs to read the predicted number from the neural network. The results of this laboratory test and the Keras routine showed a comparable accuracy of 97%, sorry, and most importantly, the computational time, which was the target of this test, showed a difference of several order of magnitudes in the computational time between CPU implemented neural network and FPGA implemented neural network. In particular, over the strict computational time, the fixed value of the latency for the FPGA respect to the CPU implementation showed the most important characteristic of the FPGA implemented algorithm, which is again the fixed value of the latency to be able to know and predict when an algorithm will complete its task. So, in conclusion, the necessity of heterogeneous architecture, which are architectures that explore all the possible type of devices like CPU, FPGA, CPU, and GPU, and ASIC, is becoming crucial to achieve important future challenge. For example, the trigger of the high energy physics experiment at CERN. The Bologna group collaborate with the Atlas experiment at CERN and has developed years of experience with firmware FPGA developing. And in this moment, gaining even important information from this type of test too, is studying proposal for the trigger of the upgrade of the Atlas experiment. concluding, this test has been done collaborating with other people other than me, FPGA experts, which the FPGA expert is me in this case, and the neural network expert, which is a person not present today. But this was to explain that this, let's say, cross-boundary test and experiment necessity a collaboration between different expertises, and they are necessary to show the capability and the pros of today's generation of FPGA-based solution. Thanks for your attention. I'm done. Are there any other questions? Are there any questions? Sorry.
Thanks, Fabrizio, for this presentation, for the explanation of the work. Question from Fabrizio? So actually, Fabrizio, we have one quick question because the time is not from our side. But in any case, let me ask you, future activity, future work on starting from the work that you did and you present.
In the ATAS activities, there are many groups that are working on the implementation of a neural network for the trigger for the ATAS trigger. By our sides, we are not working on the implementation of neural network, but we are working on tracking algorithm, in particular the one that I wrote in these slides, the half-transform algorithm, which is a known tracking algorithm that it has been studied to be implemented on FPGA because it has an important and a significant accuracy in terms of tracking, but it requires a very deep parallelization of it to be able to gain the correct performance, and in particular in this case FPGA, the FPGA devices are built and are developed to be able to explore a very high level of parallelization. So to answer your question, we are working we are studying the implementation of the half-transform algorithm, which is not a neural network but a tracking algorithm, on FPGA for the future Atlas trigger system.
Okay. Let's see this in another presentation, maybe.
Yes, we are watching it now, but yes.
Thank you for this presentation.
Try to remove my sharing. Okay,
thank you. So, and thank you again, Fabrizio. And then I ask Karuna Babber to be prepared for the next talk. Karuna, are you here? Karuna? Can you hear me, all of you?
Yes, yes.
Okay. So, okay, maybe we can pass over. Maybe we can get back to Karuna after that in order to do not lose too much time. The next in the slide is Valentino Santucci.
Yes,
Valentino, are you here?
I can hear you, yes. Let me share.
Yes, in the meantime, I will present you. Valentino is from the University of Strangers in Perugia, in Perugia, and he is going to present the paper ID 408, Learning to Classify Next Complexity for the Italian Language Using Support Vector Machine. Valentino, I can see your slide, and please, the floor is yours.
Okay, so good morning to everyone. This is a joint work with other colleagues from the University for Foreigners and also colleagues from the other University of Perugia. Okay, in this work I will talk, the work is about natural language processing. I will show you in which sector of NLP this work is. I show you some objectives of the work, the dataset we have collected, the architecture of the system we have realized, the linguistic features used, the classifier model, some experimental results, and then at the end I will draw some conclusions. So natural language processing is we can say that it is just a rebranding of the computational linguistic science that was going on from much of the year. Okay, of course, a rebranding using new tools, new deep learning methods from machine learning fields. Okay, NLP deals with a variety of tasks. Some of them are listed here, like named entity recognition, machine translation, sentiment analysis, and also text classification. That is what we are doing in this work. Okay, so our scenario is to automatically classify text to be used for language learning purposes. Let's say texts that are didactic materials or text used as assignment to assess the level of a candidate student. Okay, this is our final objective. We have a few constraints, just two. Our texts have to be in Italian, in the Italian language. Okay, the other constraint is that the complexity of the text is classified according to four labels. Okay, the B1, B2, C1, C2, that are the common classification of the language proficiency by the common European framework. Okay, and so what we have now, which data we have, why we decided to do this work? Because at the University for Foreigners of Perugia, we have a center for the evaluation of the Italian proficiency and also for releasing a certification about Italian proficiency. Okay, so we have some experts, some linguistic scholars, and we were able to collect around 700 texts, and every text is has a label that is assigned by a linguistic expert of our Center for Evaluations. This is the dataset, and now it is divided. You can see that we have the 4 class levels from B1 to C2, and this is the number of texts in every level, and this is the number of total tokens in every level. You can see that the dataset is a bit unbalanced, okay, and you can also see that one important feature to analyze the complexity of a text is for sure the length of the text, because you can see that B1 is the bigger. We have a lot of text in B1, but fewer tokens in total. Okay, so we already have an idea. So going on, this is what we had and what we have. Sorry. And since we have a dataset that has labels, we can cast our program to supervise the classification problem. And anyway, we have text. It is ideal for machine learning algorithms to have numerical features, maybe. So our idea was to project any text into a vectorial space, so a space of a feature space, let's say. So any text will become a vector of numbers. And these numbers are computed by using some linguistic features. Okay. Once we have the instances of numerical vectors, now we are working with numerical vectors. We can use any classification model from the literature, from the machine learning literature. So we can train this model with our dataset. And when we see an unseen text, we can predict its complexity level by converting such text to a numerical vector, and then run the trained classification model on this vector. So this is a big picture of our architecture. You can see here there are the text, and there is here a component that is linguistic features extraction. Importantly, this is based on a NLP pipeline. We will see later what is. Here we have the labeled vectors, we have the training phase, we build our classification model that can be used to predict the proficiency level of any unseen text that is converted to numerical vectors. So let's see component by component this architecture. First of all, we have to find a way to extract numerical features from the text. To do this, we use some tools that are in literature. These tools are called NLP pipeline tools, and they are able to extract from a text a tokenization of this text, a lemmatization of this text. For every token, for every word of the text, we can obtain the part of speech tag of this word, and then for every sentence, these tools are able to build trees about the words of the sentence, and every arrow that connects to words in the sentence as a label that has a syntactic meaning. Okay. Of course, there are a lot of different pipeline tools for the English language, not so much for the Italian. We found just 3 different NLP pipelines tools, and after a few preliminary investigation, we decided to proceed with this one, UDPipe. Okay. So, using the output of UDPipe, now we have to build some algorithms to compute the features. In total, we have computed 139 numerical features. They can be divided into these categories. There are the easy features, the root text features, like the length in token, the number of unique lemmas in the text, and so on. There are lexical features, like the number of words that are in the text, and they appear in a standard dictionary of highly available words for the Italian. There are morphological features like statistics about the post-tax distributions, the verbal mode distribution, and so on. Sorry. Maybe the most interesting from a computational point of view are the syntactic features, like computing the depth of a tree, of the parse tree of the text, the arity of the verbal nodes in this tree, and so on. So at the end, we have anyway around 140 numerical features. So we can apply a classifier model. We decided to use the support vector machines. We decided to not use neural network because our dataset is only around 700 instances, so it's not so big to use neural networks. We use the SVM. And this is the configuration we have adopted, radial basis function as kernel of the SVM, and these are the hyperparameters that we have calibrated using a grid search. Okay, let's go on. First experiment was to study if all the features are important or not. So to do this, we have used recursive features elimination technique. check if the features, all the features are important. And okay, we also have used this technique here, permutation features importance. At the end, in this chart, you can see that we have on the x-axis the number of features. Okay, on the y-axis we have the F1 score. We use the F1 score because our dataset is a bit unbalanced, and we can see that we reach the top performance by using 54 features. Okay, I will not show you in this work which are the features most important or not, because I think this is of interest for linguistic people. I'm a computer scientist, so I'm not able to describe you, but we provided such information to domain experts. And I found it useful, of course. And okay, some other experimental results. We did 10-fold stratified cross-validation, repeating our experiment 5 times. We found a final accuracy of almost 72%. Okay, it's not really big, but we have 4 classes. It's a random classifier. It's only 25. Let's remember this. And our dataset was not too big. Okay. Anyway, something important is the macro levels accuracy. The idea is that if we take only 2 classes, B and C, okay, so B1 and B2 become B, and C1 and C2 become C, our accuracy improve to almost 90%. And interestingly, we also studied if the raw results obtained in this confusion matrix are in line or not with the 2-dimensional visualization extracted from the dataset using this is a neural network tool that allows to visualize a multidimensional dataset. This new. Okay, and we found that the class B1, the green one, and the class C2, the gray one, are easy to separate. Okay, and also our results are in line with it because the number of instances that are B1 and predicted as C2 are 0. So we were able to separate this. And when we have some errors, most of the errors are only 1 level away. What I mean with the 1 level away? Let's say we are here. Most of the error are in B2, not in C1 or C2, because okay, this is an error, but it's a bigger error than classifying it. So this is the idea. So also, if we do not have very lot of instances of text, we obtain the good results, and we are satisfied about it. So conclusions. At the end, we have developed an automatic tool for measuring the difficulty of the text in the Italian language. We also provided a web interface for the Italian teachers at our university, not only the teachers, but also the linguistic people that write the text for the assignments. Okay, as a future works, we are already trying other classification models. Okay, also neural network, random forest, base classifier, and so on. And another interesting line of research is for sure to extend our dataset, our corpus of text. And that's all. Thank you for your attention. And if there are questions.
Thank you, Valentino, for this presentation. Are questions from Valentino? Actually, I have one, Valentino, for you. As you said in the middle of the slide, that there are not so many instruments and services for for this kind for Italian languages, how your work and is far to be considered in say production environment.
Yeah, yes.
I mean,
already
use it also for other let's say for other things, for other aspects also outside your university.
Okay. I have to separate the answer in two answers. In the middle of my slides, there are some tools that are used as a base to build other tools. They are used for very base for very base problems like find tokenization and lemmas and so on. And these are tools that are in the literature. They are free for Italian, and not all of them are EV trained, so they do not work really well for the Italian, at least in comparison with English. The other answer is our tool. Okay, our tool is used in our university, but is already online accessible to the world, and the link is on the paper if you want to see it and use it.
Okay, many thanks. Thank you for the clear answer.
You're welcome.
So, other question to Valentino? No? Thank you, Valentino, for this presentation. Many thanks.
Thank you, bye.
And I'm step back to Karuna Baber. Karuna, are you here?
Yeah, good morning, sir. Good morning, sir.
Okay, Karuna. So please share your screen, and in the meantime, I will present your work. Here we have Karuna Baber from paper ED 171. Yes, she is assistant professor for postgraduate government college, and she is going to present right now the work on artificial intelligence in healthcare, predictive analysis on diabetes using machine learning algorithm.
Okay.
Karuna, the floor is yours.
Okay, good morning, sir. Good morning, everyone. My topic is artificial intelligence in healthcare predictive analysis on diabetes using machine learning algorithms, and I am Dr. Karuna Babar from Chandigarh, India. I hope all of you must see my slides over here. Okay, should I continue?
But you are in the first slide.
Sorry?
Actually, I see the slide from the last presenter. I don't know what you can see.
I see the slide of Karuna Baber, but I see the first slide.
You are saying my first slide?
Yes, the presentation.
Okay, right, good. Yes, right.
So, Karuna, let me remember that we are slightly in late, so please go on. You have 15 minutes in total.
Okay, right, sir. The outline of my paper are introduction, data results, followed by result analysis and discussion with conclusion and references. Going up. Big data repository for healthcare. I have presented, as we all know, we have gathered so much of healthcare data so far, like medical prescriptions, clinical reports. We are able device data, lab examination data. We have gathered data, healthcare data from all over the world. Now the time is to assess that data for actionable, intelligent information, to fetch actionable, intelligent data information out of it. For that, we need to clean the data, process the data, and more importantly, to extract good features out of it, to extract valuable features which are required for further analysis. Then we can also implement machine learning on this healthcare data repository, like to integrate all types of patients' data, event sequencing on electronic healthcare records. Robotic surgical procedures can also be performed using machine learning algorithms. Then to provide real-time clinical care to patients, we can use machine learning, particularly machine learning algorithms for real-time clinical care of the patients. And then we can also help to cut the ever-growing costs of health insurances in particular. The data we for our observation, we have picked PIMA Indian Diabetes Database collected by National Institute of Diabetes and Digestive Kidney Diseases, and our observational data comprises of following parameters like blood pressure, body mass index, age, diabetes pedigree, function, skin thickness, and glucose level. In our data, firstly we implemented we import pandas library file to read our dataset, and then by applying statistical tools we split our dataset into two outcomes, that is zero represents our non-diabetic people and one represents our diabetic people. As the graph also is showing, our zero output for non-diabetic people and one output for our diabetic people. Coming to other results, my first feature is blood pressure. To find the correlation between blood pressure and diabetes, the bar graphs are provided below. For non-diabetic people, the BP value, that is blood pressure value, comes around 60 to 75, whereas for diabetic people, the BP plot is little skewed towards the right and the value comes around 75 to 85. Again, in my box plot in the next slide, you can very well see that around 75% diabetic people have BP in the range of 75 to 85 mmg, whereas around 75% non-diabetic people have a BP range 70 to 75 mmgh. Secondly, the maximum value of BP for non-diabetic lies at 100, whereas it is at 110. That too with outliers in case of diabetic people. Both the plots, whether it is histogram or a box plot, both indicate strong association between blood pressure and the diabetes of the patients. Next feature which I took is age of people. From graph 1, it is clear that people within the age of 20 or mid-20s are non-diabetic, whereas people with age 30 and above are prone to diabetes. In the box plot also, for non-diabetic people, the median is at 25 years, whereas for diabetic people, the median is at 32 years. But both the plots indicate moderate correlation. From the histogram as well as from the box plot, we can indicate both the plots indicate a moderate, you can say a weak correlation between the two features. Coming down to my next feature, that is body mass index. The graph 1 shows the BMI level of all the people within the different age groups. In graph 2, the BMI level peak is from 28 to 32 for non-diabetic people, whereas it is skewed and it is tilted towards the right at 36 for the diabetic people, as you can see here in my graph. Again, in the box plot also, more than 50% diabetic people have a high BMI level as against non-diabetic people. You can see here. Moreover, for diabetic people, some outliers are beyond maxima, whereas it is not the case for non-diabetic people. Thus, a strong correlation between BMI and diabetes is indicated. My next feature is diabetes pedigree function. Here in graph 1, histograph 1, DPF count of all the people within the different age groups has been taken. In graph 2, the peak of DPF count comes at 0.125. 0.125 for non-diabetic people, whereas it is at 0.25 for diabetic people. Again, in my box plot, the box plot shows more than 50% non-diabetic people have a DPF count of 0.4. 0.4, and it is slightly more with 0.525 DPF count for diabetic people. Secondly, both the plots have outliers beyond maxima, so a weak correlation is indicated between the two features. My next feature is skin thickness. Graph 1 provides the skin thickness of both the outcomes, that is for diabetic and non-diabetic people. Non-diabetic people represents 0 and diabetic people represents 1. In graph 2, the peak is at 30. The peak is at 30 for non-diabetic people, whereas it is at 40 for diabetic people. Again, in my box plot, you can see more than 50% non-diabetic people have a skin thickness of 28, whereas the skin thickness count is 34 for more than 50% diabetic people. Secondly, very few outliers are beyond the maxima in both the cases, and the difference between the maximum value for both diabetic and non-diabetic people is only 3 points. The graph indicates nominal relationship between the two features. My next feature is glucose level. Graph 1 provides the glucose level of both the outcomes, that is for non-diabetic as well as diabetic people. In graph 2, the glucose level range of non-diabetic people is between 85 to 105 mgtl, whereas the range for diabetic people comes in between 120 to 200, a substantial rise, I must say. In box plot also, you can see that more than 50% of non-diabetic people have a glucose level of 100 to 110 mgtl, but more than 50% diabetic people have a range of above 140 mgtl, a quite substantial rise. Secondly, the maximum value for non-diabetic people is 150 mgdl, whereas it is 200 mgdl in case of diabetic people. Both the graphs indicate a strong correlation between the two parameters. Result analysis. Now coming down to my result analysis and discussion, I have used machine learning algorithms like logistic regression, support vector classifier, linear support vector classifier, and all these classifiers have performed well with high mean accuracy rate as compared to decision tree, Gaussian naive, and random forest classifiers. These machine learning algorithms, especially the decision tree, Gaussian, random forest classifiers, may work well when the classes are more. But as we have only two classes here, we have binary classification here. So the logistic and based about the data set, the quality of the data set, logistic regression, support vector classifier, and linear support vector classifiers performed really well and with higher mean accuracy rate, as you can see it in my table also. With the box plots also, the box plot also provides the interquartile range of all the machine learning algorithms, and as you can see the range here also, which I have already submitted in my tabular form also. Now, coming down to my conclusion, by applying the thumb rule of correlation and inferences received by applying machine learning algorithms, we can infer that blood pressure, body mass index, and glucose levels of people showed strong correlation with diabetes, whereas diabetes pedigree function count, age, and skin thickness have signaled moderate correlation with diabetes. Although present analysis attested many of the previous research findings, but getting these inferences matched through analytical tools is the sole purpose of this paper. These are few of the references I have referred. Thank you so much. Now, any queries?
Many thanks, Karuna, for this fast presentation, even if complete presentation. Thank you very much. Any question from Karuna?
Thank you.
Actually, I have one, Karuna, for you. Just a quick question. Future development and use of this work.
Sorry?
Future development. Which are the future development that you are planning to do?
Yes, sir. I want to implement it. I want to just extend my data set also, and I want to repeat these tests on few of the other machine learning algorithms for further better results and for higher accuracy.
Okay, thank you. Many thanks.
Thank you.
Other question for Karuna? I suppose no. So let me thank you, Karuna, again for this nice presentation.
Thank you so much, sir. Thank you.
Then I will invite to share the screen to Mortis Lange. Mortis, are you here?
Yes, I'm here.
Okay, so please share your slide, and in the meantime, I will present you. Here we have Mortis Lange from paper ED 46. He is from the University of Applied Science and Arts in Hanover. And today he will present us the work titled Dealing with the Data Streams, Complex Event Processing versus Data Stream Mining.
Thank you very much.
So the floor is yours. Mortis, please, go on.
So, do you see my slides?
Yes, I can.
Very good. So, okay. Yeah, good morning, everyone. Thanks for the invitation. I'm Moritz from the University of Applied Science and Arts, Hanover. And in the next few minutes, I'd like to talk about complex event processing and data stream mining to help you to understand why this paper was written and why I decided to publish it at this conference. I first to give you some context and motivation. So imagine me 1 year ago. This is me, by the way. I was in the second semester of my master studies, and it's just started, and I realized I have to write a seminar paper. So there were different seminar groups, each of one dealing with different research topics of different fields of computer science. And fortunately, all the stars were right in the right order, and I was assigned to the group data mining and not to the computer graphics. So it should be said that normally I do research in the field of software architectures and distributed systems. So all this microservice and so on stuff. And this whole data mining and stream processing topic was relatively new for me at this time. Then the day came when the topics for the papers were assigned to the students, and I was thinking, yeah, complex event processing versus data stream mining. This sounds like a very simple topic. So complex event processing, this is something I've heard in a lecture before, and data mining, this is the thing with clustering. So I will simply define both things and compare them a little bit, how hard it could be. Pretty motivated, I went straight to it and borrowed some basic literature on complex event processing and data stream mining from the library and began to read. And I started to examine the literature on complex event processing because this was something I've already heard a lot of in a lecture. And to keep an overview, I took a sheet of paper to write down the most important definitions for me. And imagine this slide here was my paper. And the first two things I wrote on the paper, you see, were complex event processing and data stream mining. In the hope, after reading all the literature, I would have a definition for both and can simply compare them. After a short time reading, I found the first term that made me think. So there was event stream processing. And I thought, did I have the wrong book? I wanted complex event processing, not event streams. Or is this the same? Before I could find out the answer to this question, the next term came already up, and there was event processing and data stream processing and stream processing. The more terms I collected, the harder it was to distinguish them, and the more the border between data stream mining and complex event processing became blurred. And this flood of new terms never stopped during my research. There was data analysis, data stream analysis, data mining, knowledge discovery from data streams, data analytics, data science, intelligent data analytics, real-time intelligence, and real-time data mining. And as soon as I've opened a new book or read a paper with keywords complex event processing or data stream mining, at least one new term was introduced. At this moment, I knew I was in big trouble with my seminar. And believe me, this is only a small part of my term collection. And I have not mentioned any of the German terms like Ereignisdatenstromverarbeitung. I thought it would be fun to mention that. After 6 weeks of exhaustive literature research, I was completely confused. So, although many papers use these techniques together, I could not find any literature that explains me the difference between these two. At the same time, the basic literature on the techniques are disjoint. So, while there is little talk about data mining in complex event processing book, data mining literature hardly says anything about complex event processing. And to close this gap and blow away a little bit this fog in this semantically overloaded domain of computer science, our paper presents the basics of both techniques and compares them. So since a detailed presentation of the basics would exceed the time frame of this presentation, I will limit myself today to a short content overview and a presentation of the comparison, of course. Okay, what's inside our paper? Since both techniques are used to process data streams, we first defined the concept of data stream and showed the difference to traditional data. We also discussed characteristics like possible concept drift and a massive domain, which techniques for processing data streams have to deal with it. And after defining data streams as an input for both techniques, I would say input, we introduced complex event processing with its concepts and defined event streams as a form of data streams. So after we introduced the fundamentals of data mining and presented some general techniques how to apply data mining algorithms for data streams. And I think for us, hopefully you will agree, this is the definition of data stream mining. So data mining on streams, this is data stream mining. And okay, let's jump to the comparison. First of all, we can say that both techniques are used for process data streams, of course. And in context of complex event processing, the concept event abstracts from the raw data elements, but under the hood, event streams are the same as data streams. So this is also the reason why both techniques are using the same methods for processing streams. In literature, however, the techniques for complex event processing are limited to the sliding window. Although both techniques deal with data streams, they have their origins in quite different fields of computer science. While complex event processing has evolved from rule-based systems, data stream mining has evolved from traditional data analysis through advances in hardware and software. So this could be also the reason why this literature is so disjoint. In my opinion, the main difference between complex event processing and data stream mining is that complex event processing is about simply matching predefined structures on sliding windows, while data stream mining is about discovering new patterns and knowledge on streams. This, of course, does not exclude the possibility to combine these two techniques. For example, to use data stream mining to find rules of a subsystem at runtime to react to a possible concept drift. This would be an example, and this is also common in practice. And okay, to sum things up, we have created a paper that introduces the basics of data stream mining and complex event processing and compare them. What sounds at the first glance pretty simple, but another reason why I'm publishing this paper is because I have received a lot of positive feedback from other students who have read my paper over the past year, and I have been asked a few times even if they could quote me in their thesis. And for me, this is a clear sign that there is a lack of literature in this area, and the paper is therefore a good compact introductory literature for everyone who is interested in data stream processing and doesn't want to read the whole data mining and the whole SAP literature. So, but also for experienced readers, I think this paper can help to choose the right techniques or the right combination of techniques for a case. So while this paper gives an overview of the two techniques and aims to show the origins and difference of both, further papers of us will deal with more recent findings and from the two research fields. And our main goal of our future work is the development of a decision framework that allows a user to determine the right techniques or the right combination of techniques for a specific application. And yeah, that's all of it. Thank you for your time and your attention, and feel free to ask questions.
Okay, thank you, Morsi. Thank you very much. And question for Morty? Okay. If not, thank you, Mortis, for your valuable work, and good luck for your activity and your work in this field. It's very interesting topic. So with Mortis, we reach the end of the presentation. It is a very interesting activity. It's a very interesting presentation and very interesting outcomes from this workshop. Many ideas now are, let's say, have been produced and have been described. And I don't know. Let's try to let's say discuss a bit outside of this meeting. I really like to thank all the presenters and all the attendees here. Many thanks also to the host for this conference. And before to close, I really like to remind you that all the presentations that have been presented today are in the Riot platform under the AMDA workshop session. So if you want, you can go there and maybe start a discussion with the interested people. We are almost in time, I think, Lucia. So
yes.
Thank again for to be present here and for your time and for your valuable work today. Many thanks, and see you next time.
Thank you so much. Good morning, Flavia.
Good morning. Good morning. Everything is okay?
Yes.
Great.
Are you the speaker for this session?
Yes, I suppose. At
Okay.
11 o'clock. Yeah.
Okay. I am the assistant for this session.
Great. Great. Yeah, my paper written together with Luigi Mondula.
Okay. If you want to try to share the screen.
Yes, just a second. So let's try. Let's try.
Ciao, Flavia.
Oh, is it correct?
Yes, perfect.
Okay, great. So how can I? It's okay. Now it's not anymore. Yeah. How can I cut it off?
You have the button. Turn off. Okay, perfect.
It's okay now.
Yes.
Fine.
For the other participant, if you want to put your name, that is more simple to interact. You can do it by click on the three dots on the corner in the bottom left. You have the first line, and in me, you can put your name if you want.
Corner bottom left. My name is there is my name in the the script?
Not yet.
Luigi. Where is the bottom?
I can share my screen and you show. Okay, you can see my screen.
Yeah.
There is this 3 button, and in this first line, you can put your name.
Okay.
Yeah.
Okay. I find it.
Okay, Luigi, are you the chair for this session? Yes?
Yes.
Okay, nice to meet you.
Nice to meet you too.
You
And
should wait until 11, right?
Yes. And Luigi, I remember you to fill out the evaluation form at the end of the session.
Yes, thanks.
Thank you.
I know. Beniamino is just 3 or 5 mail about this.
How many people you imagine there will be present? Do you have an idea?
Oh, 14.
Okay. So we still have to wait because.
No, I think we are there are 3 presentations.
And there is a lot of parallel sessions, so really it will be hard. So for the moment we are 8, right? I cannot see you, Luigi.
So good morning, here's Boris Bantam from Germany.
Morning.
Nice to meet you. Morning. Okay.
How is the weather in Cagliari today? What?
Windy.
Windy. Ah, great. So not very hot.
Yes, but it's not so comfortable. Lot of wind. Too much.
So 1 minute left. How many people are there in this session after hours?
I don't know.
I don't know. It depends.
And we have 8 minutes, right?
Yeah, 8 minutes plus 2 for questions.
For questions, yeah. I see that after hours. Oh yeah, 11:10. There is another one, and 11:20. There is another one too. Okay. So
Yes,
you must
but
be sharp.
Luigi, if you want more time, it's possible because in this session you have only 3 presentations. It's only important that we finish at 12, but if you want more time, it's no problem.
It's a lot of extension. 1 hour for 3 presentations.
It's enough, yeah. Well, depends. If there is some good question and we can interact with participants, it's okay. If they don't have any question, we go on. So the presentation is roughly about 8 minutes, so I can go slowly maybe instead of running.
Okay, maybe we can start with 10 minutes and then.
Okay. Yes. And if you want to start,
yeah,
it's time.
Is registered the session or not?
Yes, yes, we are online on YouTube.
Great. Great. Starting now or?
No, it's continuously from this morning. Yes.
Okay.
It's one live.
We are already online.
All our nice consideration about wind
Yes.
of Cagliari and other nice things are on YouTube. So please take care about what you're doing or thinking about.
Welcome, George.
So,
tell me whenever.
Okay, so we can start with this session. Our session is about open knowledge, and this topic is wide, of course, but the authors, the contributors for the session highlight some interesting topics. So we can start with presentation of Flavia Marzano about smart communities and knowledge sharing as main tools to achieve common purpose. And so, floor is yours, Flavia.
Thank you. Thank you. Thank you very much. It is a pleasure, really, to be here today. And so we are talking about smart communities and knowledge sharing. Can you see the slides, right?
Yeah.
Okay, great. So I can go on. So this is a paper written together with Luigi. I'm calling myself a why notter. I try to do my best to be a why notter instead of a yes butter, let's say. I'm a computer scientist, and we will publish these slides if you want on SlideShare, so you can share it, and I can go faster on this kind of slides. This is Luigi Mundula. We wrote together this paper, so that's why we are presenting this paper together. So talking about an information society for all, we said that it's still true, we need it, but the first time we hear it was from Europe in 2000, so 20 years ago. They were talking about digital age. Wow. It's not really true now, and creating digitally literate Europe, and it is not true either. So we have to work on that. Innovation and knowledge diffusion. Well, knowledge sharing is essential, of course, but what do we need? Innovation requires skills, of course, but knowledge diffusion for the other side, so learning. And the phases of innovation are different, and you must know it probably, but an interest model for the diffusion of innovation is that of contagion. And contagion by proximity, and contact. Well, we learn it from epidemiology in this period much more than usually. So continuing on innovation and knowledge diffusion, an important example is the technology transfer. What do we transfer? Technical elements, techniques, of course, and in the broad sense, know-how, training. And the success of technology transfer involves a modification of all the components of the technology, all the components. And the problem for the other side is the intellectual property right, property protection. The TRIPS agreement is a way to standardize protection, but the risk is we will favor the north of the world at the expenses of the south. So we think that it is much better the digital revolution of Creative Commons. So starting from the CC0, where I give every rights to others, to all the other possibilities, so attribution, share alike, derivatives, non-commercial, but it's much better than the strict copyright. So it allows much better knowledge diffusion. Another way to diffuse, of course, knowledge is open source, open data, and through communities and influencer. The idea is starting from what President Obama said in 2009 about open government, and the way to avoid to replace the NIH, the Not Invented Here syndrome, with the Proudly Found Elsewhere syndrome, is what we'd like to do. Talking about open source in public administration buying software has some constraints, legal, technical, economical constraints, and they have to keep in mind that they're spending public money for public interest, so they have some common rules. They need some common rules. What they have to ensure in buying software: availability of source code, at least for inspection and traceability. Continuity of data, possibility to read data whenever in the future. Integration with the software already in use, of course. Pluralism, competition, security, interoperability, and cooperation. And in buying software, public administration must be at least be proprietary of the structure of data. They have to work on that. To be sure, to be able to share software suppliers, so to change software suppliers. So they have to avoid the lock-in. Be sure that the software acquired do not have some backdoors. And software based on open standards, because they have to interoperate with others, get better price performance solution, and verify the total cost of ownership, better the social total cost of ownership. In giving information, public administration must also grant something to citizens, at least transparency and privacy, accessibility also for people with disability. The website, the information on the website must be readable from people with disabilities. Possibility to export data, open government data, and possibility to read documents without having to buy any license, any software. How can this be done? Adopting open standard, at least, and open source solution. Sometimes would be better to have a compulsory by law in order to grant some requirements. And we do not have to forget the 17 SDGs, the goals for sustainable world, and the advantage for citizens can be those. So favoring sustainable economic and social development, increasing internal ICT competences, and forming communities among PAs. So reducing the digital divide too. What do we still miss? Open access, trust between citizens and public administration at least, innovation, awareness, and political commitment. So we need more political commitment in that field. There are so many good experiences. The best and the easiest to find is Wikimedia Foundation, the Free Software Foundation, and all the communities in open source. So LibreOffice is one of those, or Linux, or whatever. And talking about the digital sharing for the territorial fruition, there is a strong role of GIS tool, which is important to reinforce the resilience response of community to stress. And cloud computing can be a way to solve a lot of problems generated by technologies. We have to move toward a transition from a network of documents to a network of data and people. We are already a community. So we should switch from a smart community, could be just technical people, to a resilient community able to solve and include and working together. So that's our strong opinion, saying that we is much better than me. What are the elements? The systems, of course. The social agent, so individual, family, business, association, and the smart community is a place to share objective and knowledge. So collaboration, we is much better to share spaces, experience, knowledge. An example is the slow tourism, not only creation from below of new routes, but also routes in the territory and creation of new connection and new opportunities. So data, information, perception together become a common good and an element of reconstitution of the social fabric. Internet is a place we know it since many years. In the beginning was just offering monologues. Now is a conversation through social media, is a new way of being connected. We experimented this during the lockdown very strongly. Fortunately, we had internet to be able to get in contact with other people. It is also driven by influenza. We have to think about that. So what do we need? We need a new vision, mainly for sharing knowledge, sharing ideas. What do we lose in sharing? What do we gain in sharing? Mainly sharing multiplies experience, knowledge, ideas. That's why we do believe that sharing is important. So what Seneca said about that is that the best ideas are common property. So we have to keep calm and co-design together. Politicians and citizens participate and collaborate. That's the way. And talking about knowledge sharing, all the presentations are based on CCR or on CC, attribution and share alike. So that's a first way to work on that. Thank you very much for your attention.
Oh. Thank you, Flavia. Your presentation is always very, very nice, very involving. And there is some question from the floor. Okay, just one, even if one of the co-authors, but just to ice break. And do you think there is some limit, some threats in the open access adoption from the public administration, or is the open access is only positive for the public administration?
Well, depends. What do you mean about open administration or public administration? If you think about municipalities and regions and governments, I really think that there is no constraint. They have just to open. I mean, concerning, of course, the GDPR, so privacy, of course, security, of course, so some information should be protected by, but public administration have to open all the information possibly. For the university point of view can be different because the university have to publish, the researchers have to publish books, and normally is a bit different. It's a bit difficult, but well, sharing knowledge will be a plus. Is a win-win solution in my opinion. Okay. I don't know whether everybody agrees. If they don't, we can talk about, of course.
So I just want to give from Germany. Yes, I would agree, totally agree. We should share our knowledge, and even for countries which are not so proper, it's very important to get the same knowledge as proper countries have.
Yeah, in fact, there is what is it? Can we say that commercial ICT's response to open source is kind of adaptation of crowdsourcing using advantage and direct support for clients, also with elements of open source scripting? So I would say yes. I think the commercial firms also sharing their product. They have to. I mean, they can be able to do it. They can have both. Like, think about cloud. This is another idea. Cloud can be public, can be private, can be hybrid. Talking about public administration, they can be hybrid in the sense that as a public administration, I have to keep all the sensible data in my own cloud. But if they are, let's say, mobility data, I can give it to a company, a private company. Why not? In the similar way, yeah. No. In the similar way, we can do it through software.
There is an intervention, a request intervention by Werner, please.
Yes, I would like to say that I was listening on YouTube and I asked it on YouTube, but I don't know why this question didn't pass through the network. I would like to say that I think that taken as example the most the greatest firms like Microsoft, who changed their attitude to open source, or Google, who is using, and I think that this is a kind of changing nature of open source. The open source was quite a long time treated as not as diminishing thread of ITC, but for the moment, I think that it would be the main trend to develop. For example, take a look for participatory planning using spatial.
Yeah, exactly.
Thank you. I'm sorry.
Yeah, and thinking about after this lockdown, if we want as a, let's say, national governments, we want as a Europe at least to reinforce our industries, our factories. So what can we do with open source? We can give our money to develop, to give better solutions, starting from open source solutions and working inside. So we give our money to our community, to local industries. So that's something that we should do as governing the local territories.
Thank you very much for your presentation. It was very interesting.
Thank you. So, not anybody? Luigi, up to you.
Luigi, can you hear?
Sorry, I closed my the Microsoft. I was talking with myself.
Okay. Okay.
Of course, I said a lot of very interesting things, but the microphone was off, so I'm sorry. So we can pass with the second presentation, and that is very actual, because it's about the impact of the COVID on the socioeconomic issues on the Black Sea region countries. So the floor is, I think, George is the presenter. Is right?
Hello, I am the presenter.
No? Okay.
I am next co-author.
Okay, floor is yours, please.
Can I share my screen?
You have to shake your PC 3 times. No, I'm joking.
Just.
Okay. We see your screen, I think, but not the presentation.
Maybe. I hope there is some problem to share. Just.
Are you using Chrome?
Yeah.
Browser?
Yes.
Okay.
I use Chrome.
Sorry, have you opened your presentation on your laptop?
But I could see your screen. So
yes, we see the screen, but not the presentation. The main...
just start the presentation, maybe.
But it's blocked.
Wow.
Not now. We can see what's up.
Update us about it. Can you give some information about the situation?
But do you have the presentation? Do you have the presentation on Riot platform?
Maybe we lost the connection. Maybe.
No,
Or not?
I'm
No.
online, but I can share.
But if you like, we can switch the presentation. If there is already the other presenter, and you try to solve the problem in the meantime.
Yes, it's better.
I don't know how can I solve the problem because the presentation is on my desktop and I can't share. I don't know why.
Okay, if you want, I can share your presentation and you can only talk.
Yes,
It's okay for you.
if you send us or if you send your presentation, you
have the presentation on. Okay, we can see only for 1 second.
You can see now.
Okay, now yes.
Yeah. Okay. Very well. Sorry for technical problem. Good morning, ladies and gentlemen. It's our great pleasure to welcome you to the 20th International Conference on Computational Science and its Application. I'm Leila Mamaladze, a PhD student at Ivan Javahishvili Tbilisi State University in Georgia. Me and my co-author George Abuselidze introduced their research about the impact of the COVID-19 outbreak on the socio-economic issues of the Black Sea region countries. Firstly, I should briefly like to outline the topics of our paper. We will be talking about the aim of the paper, research methods, a historical review, the impact of pandemics on the economy in the last centuries, pandemic and its impact on the economy nowadays, pandemic and its impact on the Black Sea region countries, and conclusion. As a result, there are developed some recommendations based on the research. Restricted traffic, international, local, social, cultural, and sport events and economic activities create new economic challenges for the world, and transport for existing economic, social, and political reality and living condition has become a completely different than depending on the scale of the challenge, the research includes to review the impact of pandemics on the economy in the last centuries, to analyze the important characteristics of the economic crisis caused by pandemic, to study the impact of the current pandemic situation of the socio-economic issues of the Black Sea region countries, and based on the result of the research, there are developed some short and long-term recommendations. So the aim of the research is to describe the impacts of pandemics on the economy from historical perspective, to review the important characteristics of the economic crisis caused by pandemics, to study the impact of the current pandemic situation, and develop some recommendation. And about research methodology, the research methodology framework includes qualitative and quantitative data analysis, statistical data gathering, and academic and normative discourse analysis. We analyze the GDP of the Black Sea region countries before and during crisis to answer the research questions. The study also used the global macroeconomic consequences of pandemic influence developed by Center for Applied Macroeconomic Analysis in the 2006, and the inclusive cost of pandemic influence risk developed by National Bureau of Economic Research in 2016. The diagram shows the impact of coronavirus on the financial markets, the historic markets false graph lines the most important financial market crashes since the 1929 Great Depression crash up to February of up to the coronavirus virus crash. The issue is especially important because even in the last centuries, humanity has had to fight several pandemics, and its meant years Spanish, Asian flu, Hong Kong, swine, and then today. The coronavirus that has emerged in our time has damaged the following sectors of the economy the most. There are manufacturing, travel and transportation, retail, energy and resources, high-tech and telecommunications, healthcare, non-profits, entertainment, universities, banking, financial sectors, and public sectors issue also. And as for the impact of the pandemic on the countries in the Black Sea region, we have considered the case of each states and the sectors of the economies that are particularly vulnerable to the pandemic and are highlighted there. In the case of Georgia, there are a tourism sector because of significant share of GDP, 11%, international money transfers, the inflow of foreign currency and the impact of the national currency on the exchange rate, and also rising risk of unemployment because of restricted activities, restaurants, aesthetic centers, non-food stores, and etc. Also, according to 2019's data, in the most important investors are the United States, China, and Japan too. In the case of Russia, the damage caused by pandemic in Russia include falling oil prices due to reduced demand and declining exports, depreciation of Russian national currency, and millions of Russians are at risk of losing their job. Then, in the case of Turkey, problems in tourism industry too, depending on its import on East Asia, which accounted for 23% of total imports in 2019, and rising unemployment as a result of the suspension of certain actors of the economy. So Ukraine's economy had started slowing down at the end of 2019 and has a pure national economic landscape. Added to this, Ukraine is also an exporter of primary commodities, for example, metals, and the price for them is going to fall significantly due to falling demand in world markets. Also, industrial production fell because of a global drop in prices and demand for iron and steel, which are important part of Ukraine GDP. Then also Bulgaria. In the case of Bulgaria, similar to the above described countries, problems have arisen in the tourism sector, which is accounting for 11.7% of GDP and 11% of total unemployment. Industrial sector, also agricultural sector, and as a result, increased unemployment rate also. Many have a huge twin deficits, high financing needs, crippled infrastructure, and a workforce crisis beginning at this year. Also, China was the main supplier of material for textile industry, and Romanian factories having business relations with Italy, and we are highly affected because of pandemic. So in early March, more than 1 million people lost their job, and among them hundreds of thousands returned in their country after losing their jobs in Italy, Spain, and United Kingdom. So the diagram shows emerging markets and developing economies. There are real GDP. Now, about the results and the conclusion, the complete analysis of the economic crisis caused by pandemic is a necessary condition to easily overcome and avoid it. Also, coronavirus has a negative aspect on almost every sector on the economy, as in the Black Sea region countries, also in the other part of the world. So Black Sea region countries will be particularly affected: tourism, manufacturing, finance, retail, entertainment, leisure, and the oil industry too in the case of Russia. So there are some recommendations based on the research. It can be said that some practical recommendations have been developed on the research of the issue. It's necessary to developing the factors influencing the country's economic sectors and establish practical methods of solving the problem based on scientific research, determine real activities by the government to avoid potential threats to crisis, and the use of additional political and economic instruments to solve current crisis caused by pandemic. Short and long-term recommendations based on scientific analysis, we think that of the problem. We think that are important because it helps the state maintain stability during the economic crisis. Thanks for your attention. Any questions or remarks?
Okay, thank you very much for your very interesting presentation, and on a topic that is it's very important in this moment. And just a consideration for before leave the room for the other participant. I think that the pandemic we are facing now has to change our way to manage the economic and socioeconomic development. And we have to change in a resilient way in terms of to be prepared for this situation and to be more flexible and in all our socioeconomic aspect of the society. So it's very important, and I see like you to highlight the main problem, highlight where this crisis affect our economies and our society. So thank you really. So I leave the floor for other questions if there are.
Yeah, I raised my hand.
Yeah.
Oh, sorry, I didn't see. Please.
Okay. Thank you for your presentation. My question would be about any comparisons between your case studies. I mean, you spoke about Ukraine, Romania, Russia. Did you see any remarkable differences in the impact of coronavirus on their economies? And if yes, did you try and understand which factors can be identified behind these differences? Thank you.
Yeah, thanks. Your interesting questions. The factors the main factors is the sector of economic that have a great share in GDP in the country, in the countries, in every country, several. For example, tourism was an economic sector that we are the most affected. In the case of Georgia and Turkey, Romania, Bulgaria, and etc. Also, the different was oil industry in the case of Russia. This factor was different in the countries of the Black Sea region. Based on the research, it can be said that there are some similar factors and some difference. For example, the rising risk of unemployment, losing their job, restricted economic activities, tourism sector, international money transfers, and depreciation national currency. So the different was oil industry in the case of Russia. To compare in the other Black Sea region countries.
Thank you.
Thank you. Thanks.
Okay, more questions? Okay, so thank you again for your presentation.
Thanks for your listening.
We have the last presentation. It's about the integrated data and service platform for smart energy network as a key component for smart city. And the presenter is a mystery. It's your.
Hello from Germany. I prepared a video just in case it's too noisy in the background. And if the internet connection is going down. So just in case, I would play it now.
Yes, you can.
Works, and it's a little bit more technically about renewables and and energy. But I hope you enjoy it.
Okay.
Oops. Can you see it?
Yes.
Yes, I see perfectly.
But is there sound? No.
No, this.
No sounds, no.
No, the song, no. No.
I believe that Jitsi do not consent to give video with sound.
Yes,
unless you share it with as a video.
Then I have to talk. So let's try again. Wait.
It's a normal when somebody present something about the smart city that technically it doesn't work. It's always happen.
So even it doesn't run now. So this is not good.
I think the problem in the presentation is the same microphone of the video, and maybe there is some conflict.
I have now a problem even to stop the presentation. It's, wait. Okay. So I'm sorry. It's
I think a solution could be used the phone or another.
No, even now the video is not running anymore. It's crashed. So,
okay.
And I can't stop it.
It's crashed on all the system is crashed.
It's the first time I'm using Jitsi, and so.
Yes, you try to refresh this page, but you disconnected and reconnected.
It's not working what I try.
Okay.
Or we can just show the slides manually by PowerPoint.
Do you have it now? I can't present now. So
my name is Jan. I'm just a co-presenter for him, but I have the slides also as PowerPoint here, so I can share my screen, and then we should just do it manually.
Yeah.
Right, just 1 second.
So don't worry. A session without technical problem is not a scientific session. So
sorry, just have to change the just have to go to Chrome. Suppose you don't.
There is problem with share screen.
Yep, right.
Okay.
Okay.
It should know my screen, right?
We see the presentation. Yeah.
Yes.
Okay. Boris, should I go on or will you jump in? Any recommendations?
Please go on, because you have then the two data streams.
Okay, I'll hurry up. Yeah, hello from my side, Jan-Philipp Exner here. I'm a colleague from Boris Brandherm from DFKI, and we just want to talk about the integrated data and service platform. So the basic background for our presentation is that due to the renewable energies, the traditional way of distributing energy is changing from much more traditional power plants, which is distributing the energy from top to down, to a more bottom-up oriented and more decentralized and more complex way of energy distribution. And what we have to do for this way is to, in our product, to design a platform who is managing this complex construction and also handles flexibilities in order to keep the network stable and efficient. And this kind of platform is a part and component we consider as very crucial in the future, and also a potential element of smart cities itself. So just want to wrap it up briefly. The SynTech program in Germany have 5 showcases for, in a way, local presentations of the way how to deal with renewable energy. So it's the biggest German program about showcases for integrating renewable energies. And our findings is from the project DesignIT. This will end during this year, and is a western part of Germany with roughly 30 million inhabitants, about 3 federal countries. And it's just a way how the energy distribution system in the year 2035 will work. Yeah, in this way, there is an automatic, right? We, as I said, we developed a data and service platform, which is about data the connection with the grid and about the respective processes, and in the end, which is our how to say, flexible and adaptable way to also create services. So we just get the data connection from all facilities together and bring them in a safe and secure data and service platform together, which is potentially adjustable for also external users, which can bring on a prognosis services and also energy supplying services, and also potentially services for issues like electromobility charging on a local scale. Yeah, and as I said, the platform itself should be safe and secure by design, with respective based on the principles of Industry 4.7. Security by design, privacy by design, and resilience by design, because the energy data itself is very crucial considered. So the common criteria about respective security layers is being considered very carefully. And the concept we are doing is being implemented directly with also energy supplying companies in their productive way. We also have a very complex modeling of rights integrated. So this means who is able to do what in this way, and it's very adjustable. And as I said, the monitoring of flexibilities is a key element for the future, because the sun is not always shining when the energy consumption is high. The wind is not always blowing when it's high. So we have to deal with flexibilities during the facilities and have to monitor them and to manage them. This component is our flexibility monitoring system, which is somehow showing how the flexibilities are reacting on the way the wind or the natural circumstances were in the over specific amount of time. And also to predict this in the future, we have very complex forecast methods. So this would have been the part where probably later on my colleague Boris can be a bit more deeper into it, because those are the prognosis system also on an AI level, because when you deal with flexibilities in electricity network, you have to know what is happening in advance in order to plan the efficiency of your facilities. This, for example, shows some results from the for Friesen, for some forecasts and prognosis, and about different methods about forecasting. And it shows that there are various ways of reaching this goal came, sometimes a bit better, sometimes a bit worse. And this basic rough construction about this flexibility handling, also with neural network, is theoretically the same for a big power plant and also for a small e-vehicle loading unit. So the principles we are designing here are very scalable and multipliable. Yeah, and these, as I said, potential all systems is a component we consider as very crucial in future smart city systems, where we have in older times these classical dashboards to see how the weather is going in the cities or whatever. We see those smart city dashboards more in an active component as smart city platforms, where you also integrate further services. You can adapt electricity measurements. And what I said is only not just seeing the grid in a digital way, but also in a realistic urban planning way, because this example shows very good from Tesla power chargers. In traditional infrastructures, you can charge a car with gas in 5 minutes, but just with easy power chargers, it takes much more longer. Means the queue behind gas stations, if I just exchange gas to electricity charging units, will be taking longer. And also local building regulations from architectural point of perspective are very sensitive in this way. How much e-vehicles can I load from the lower grid voltage area? What is possibly changing? And in the future, we have to rethink about the way new technologies will evolve and will change the world that we live in, because new technologies will emerge new stuff. This is, for instance, a future gas station, how it can look like, just thinking about drones or e-vehicles and so on. So secure operation system for the integration of renewable energies, and we designed a secure operation system for smart city. This is the findings from our project, and we hope to can go on with this research in the future. And thank you very much for your attention. So this from my side.
Okay.
Thank you, Jan. I'm amazed.
Yeah, very, very, very interesting presentation. Thank you very much. And you open a lot of suggestions with your presentation that range from smart city, our future, sharing of knowledge, and so on. So if there is some question about that, I open the floor.
Yes, I have one. If you'd be so kind and say some more about, because it is very interesting about this. I've seen photovoltaic prognosing or something like this, because I think there are a lot of different factors which, and this is quite interdisciplinary topic. Thank you.
Yeah, actually, it's a big group. We are working with many partners for the IT infrastructure. In total, 10 companies and research institutes, and it's a combination of many things. Actually, the data and service platform comes from ambient assisted living and industry 4.0. And we did a combination of the best things of it. So, and for the electricity, for the prognosis, we have some algorithms for the photovoltaic, which is on a facility level. So we do a prognosis on each photovoltaic system on its own. So we learn the behavior of each photovoltaic system, so there can be a shadow at some point, and so this is not something which we can physically model. So this is something we have to learn, because we are not aware of it in the model normally. And then we have some forecasting algorithm for loads of private households or on substation level. So we get some data on many levels, and then we are combining it with a physical model. So it's we have the topology from the electricity network. We have all the data about the cables, how long they are, which cable is lying there. So we are considering three lines, 3 phases, and we have a university which provides electricity network simulation. And we feed our forecast into this electricity network simulation, and then we get a forecast for the whole network we are considering. And so we have a 1-day forecast, and we get even some virtual sensors, because we are not measuring the whole network. We have some so the photovoltaic system, we have some smart meter data, we have some substation data, but not the whole system. But the software, so the electricity network simulation computes every point in the network. So we get data about every single item, and we can compute how much was it used. Was there too much electricity? Was there too much voltage? Something like this. And we get something like, some virtual IoT. We have a smart, how to say, some like the digital twin approach. So we have some, smart product label. So we can. So I hope this answers your question.
Let me just add one point to Piotr, because the one word he was mentioning was interdisciplinary, and this is a thing I consider as a very crucial component, because this was also the reason because we chose to bring this Tesla examples on the end, because even though from a technical and IT side, we plan everything very perfectly and carefully. In the end, we have to rethink about the implications on the physical built areas. And this is the thing, we can, in a way, make our network as good as possible and the prognosis. But in the end, we just have to rethink about what does it mean if 50% of the vehicles will be charged by electromobility? How do I orient my charging stations in the urban area and this kind of stuff? So probably in older times, we could have considered urban planning, energy distribution, and IT very in a silo perspective. But at the moment, also this was kind of a finding from this project. This is definitely a way it won't be possible in the future, and we just have to work interdisciplinary to think across borders and also to cooperate with partners from other areas.
Yeah, so just maybe say some more word. So we are even working in the field of security and privacy. So we have partners, so DFKI is one partner, we have Fraunhofer ICCSA, and we have the Helmholtz Center for security, cybersecurity. And we have some approach, which is common criteria evaluation assurance level 4. In Germany, this is the level for the smart meter security. So we can, people can check the source code and they can see how it's working, and it will be certified by an independent institute. So we get some certificate for it. And so it's a holistic approach. So if you add more services on it, the services have already the security and privacy included because of this platform. So they don't need to implement anything.
I see. May I say something very short? Because there are two. I'm a geographer. That's why I'm interested, because it's quite for me. These are two aspects: normative and descriptive. That's what you are doing. This holistic approach is a kind of descriptive approach from the empirical observations. But I can say, from my point of view, I don't know if I'm right. Am I right? But maybe please tell me more. There is also a normative aspect that we can take into account all possible normative interactions, including also all the points, all demand, point of demand, and the historical use in similar conditions, weather and social and economic conditions, and try to make an assumption and try to create a normative model of, and later it could be applied to the one day. And another question is, because you told this is 1 day prognosis from, am I right? Or you can take a look.
For the photovoltaic system, it's a 1 day prognosis. For the loads, for the private households, actually it's 1 week already, because we do it on each day. So after 1 day, I can forecast already. So if it's Wednesday, I can forecast already the next Wednesday. So it's 1 week.
Are you also would like to take into account so-called enlarging the prosumer base? Because you are also taking into account the prosumer base. Okay.
Yes. So actually, this is the part of the flexibility. So the people can register their flexibility. They can say how flexible they are, and they even can ask for money for their flexibility. So and if they provide it, so this will be checked by some algorithm. We didn't take care of this algorithm, but because it's not part of this project. But there could be an algorithm who says, yes, you get that much money or something like this, or you get something back. It doesn't need to be money. So in my point of view, I like to share and to improve the system, and then I'm fine. but other people want money. So that's, we have to find something. We have to cope with it.
I'm sorry. I'm sorry to have to stop this very interesting debate, but we overcome the maximum time of the session that in origin was 11 and 11:30. So now are 12. So
okay. Thank you very much for your very
it's an indicator of the success of the workshop. So it's very nice, very important. But if you like, we can continue the debate and our discussion in the Riot platform, or sharing our email, and of course continues this very interesting sharing of knowledge is in the line with the topic of the session. So I really many thanks all the participants for this interesting workshop, and presenter or not, and I like to see you next time for another, maybe in presence, not only online, without COVID, without pandemic emergency, and to host you in our beautiful city, and for the next time, maybe.
I have just a question. Do you provide a platform for videos and for the slides, something?
The platform is a Riot platform. There is a room. I invite you in the room, and so you can.
I mean, for the future. So for the if you want.
For the future, how can we do it?
If you want, we can send you the video. So that's.
Okay, we can maybe share the video with a mailing list. I think the easier way, or in the I don't know if Lucia has some idea about.
But I think that you can share on the Riot platform because it's active.
In the Riot platform, you share the presentation, the video,
yes.
and and you can find our email to.
Okay.
And I think there is a way.
Thank you very much.
Thank you very much to all. Thank you.
Thank you.
Thank you.
Bye-bye. Have a
Bye.
Saturday.
Thank you. Bye-bye.
Have a nice day.
Bye.
Ok, siamo rimasti noi.
Ok.
Sembrava troppo il tempo invece.